Good evening, BE enthusiasts. Welcome to the session number 1 of Current Electricity. And Current Electricity is a very important chapter, not just for boards, but also for JEE Mains, Advanced, KVPY, and all the engineering competitive exams that you are going to write, be it this very next year or the year after that. So it's a very important chapter, and there are a lot of concepts in it, and that's why I have broken the lecture into many parts. And you will be seeing every bit of this chapter in detail, right from drift velocity, current density, resistivity, and all finding the resistances, Wheatstones, the instruments, voltmeters, Wheatstone's bridge, etc. Every bit will be covered in detail. And do not worry, you guys are at the right place, and we are going to get our hands on electricity, not literally like this, but maybe by solving problems. All right, so welcome aboard to this session with me, Shreyas, your master teacher for physics at Vedantu, going live. And I hope you guys are doing fabulous, and I hope you guys get really energetic when you come to this channel, because this channel, like the name suggests, is meant to create that enthusiasm in you guys. It's meant to create that hope and build that hope so that one day you're going to crack that JEE examination. And what a lovely session we had in the morning today at 9 a.m. the Menti quiz where Ankit won. And guys, understand, it's not about just winning and losing. Do not worry, even if your marks were not there, even if your name was not there on the leaderboard, you all are winners for me, remember that. So please keep attending these sessions. Do not let the motivation down. I know some of you have your term examinations, so because of which you guys are watching the sessions after some time. That's fair enough, but do not let that momentum go, because if you have a break, then that's it. It's very hard to catch up and carry those or cover up those backlogs out there. So my advice to all of you is to make sure that the momentum is on and you guys always remain Enthuse, just like the name of our channel. So this is Shreyas here, and I have been teaching for quite some time for all the people who do not know me. And I have been mentoring students for cracking their IIT examinations. Some of my students are also in ISERs and BITS, NITs of course. And also guys, I have been teaching for quite some time, and I love physics, and that's why I'm here. And I used to also work in corporate long time back. So I have that kind of the mixed background out there. And in case you want to get in touch with me, this is my social media handle, Shreyas_Vedantu, where you can definitely get in touch. I post a lot of videos, memes, funny things, and also even my daily routines, activities, whatever it is, I post it up there. So do not forget to follow me on Instagram. That's Shreyas_Vedantu. That's my handle. So welcome Saurav, Ryan, Bhanu Prakash, Ankit, Manoj. Welcome Science Priya. I hope you guys are doing fabulous. Good evening, Uncharted, Shreyas. Hi Sneha, hi Dinesh, hi Barney, hi Achyut, hi Ashwarya, hello Maruti, hello Dr. Mohammed, welcome aboard, welcome. Hello Pranuti, I like the profile picture by the way. Hi 17S, welcome. So let's get going, and like I said, we are going to see current and electricity, but today I'm going to deal with some important fundas which a lot of people skip, but it's very important. There have been many questions on this before in JEE Mains, BitSat, and all the other competitive examinations of that type. So let's get going. I hope the josh is high. Do not let the josh down. Hello Avantika, it seems that you are a little bit new. Welcome. Hi Sai Kumar, yo. And I hope guys you have solved the homework questions, because I did not see many comments on the homework questions which I had given you. So guys, unless you are going to post few answers in the previous videos for rotation and for the previous sessions, I'm not going to give the answers. So please keep that in mind. So post the answers in the previous, not in this video, in the previous videos where I had asked you to complete some homework. Some of you have, some of you haven't. So I'm going to wait for some more time. Else I'm not going to post the answers or the solution. Remember that. So do that, guys. Hello Tanmay, welcome. So let's get going. Hello Vishwajit. Hello, welcome. So yeah, okay, let's get going. Now we have seen this property that when you are inside a conductor, the electric field is zero. Remember, the charges always get accumulated on the surface of a conductor and the charges are not present inside, and the field anywhere inside is always zero. In fact, all the points on a conductor are at the same potential. But now think about it. What do you think will happen? Okay, we have seen this. I hope you remember this. Electric field is zero. All the charges are on the surface. This is what we have seen. Now just imagine, guys, what will happen if, the field inside is not zero. Is it possible, first of all, that the field inside a conductor is not zero? Yes, it is possible. And remember, this previous property is a property of static charges, that is stationary charges. So only when the charges are stationary, the field is zero. But the field may not be zero when the charges themselves are moving. That means the moment the charges start to move, then you will see the field inside is not zero. In fact, that non-zero field applies a force which causes the motion of the charges. That is called electrodynamics. Statics is stationary, dynamics is in motion. So electrodynamics is when the force due to the electric field pushes these charges inside a conductor and they begin to move, and that's what makes current in the first place. So how do you move these charges? How do you create that field? Very simple. Create a potential difference. Look at that. There is positive over there, negative over here, and what will happen is the moment you create a potential difference, you will see the electrons inside the conductor will start moving towards the opposite side or the opposite charge. If you change or flip the sign, you will see the electrons which were moving there will start coming back over here the moment you make this as positive. See how the direction of the motion of the electrons changes. So the motion completely depends on what is the potential difference. If there is a potential difference, the electrons move this side or that side. But if you do not want the electrons to move, then completely remove it. Completely remove the potential difference. Very simple. See, now there is no potential difference, the electrons stay as it is over there. So when there is no potential difference, the electrons just keep vibrating over there. They do not leave their original position. Their average displacement is zero. The moment you will see there is a potential difference, they move towards the opposite charge. That's how it is. And remember always, yes Ankita, this is definitely going to be helpful for NEET also. And even if you are a 9th or a 10th standard student, you can still attend the lecture because it might be useful for you for NTSE or other Olympiads that you're going to write. So all the NEET aspirants are also welcome here. I know a lot of Biotonians are also here. So welcome, no problem. Okay, so now the thing is, understand in a conductor, yes Mohammed, I'm just coming to whatever you said, excellent question. So what happens when charges move? It's always the electrons which move. Now what kind of charges are they? Negative. By convention, by simplicity, we have been assuming for hundreds of years, for historical reasons, the flow of current as the flow of positive charges. So what have we been assuming? Current is nothing but flow of positive charges, but actually we know it's the flow of electrons. So if electrons move this way, it's as good as saying if negative charges are going that way, it's as good as saying positive charges are going that way. So that's why the current's direction is always opposite the direction of the electrons. Remember that. But magnitude wise it is the same, guys. Whether positive charges move this way or electrons move this way, it's one and the same thing. It's, I hope, very, very clear. Alright, why electrons move? Remember, electrons are the ones which are orbiting the nucleus. So they are free to move. The nucleus is the heavy part. If nucleus itself moves, the structure will get destroyed. The entire structure of that solid will get destroyed. So that's why the nucleus stays as it is. And not all the electrons move, let me tell you. Only the outermost electrons, the free electrons, are the ones which actually move. The inner shell orbit electrons do not actually move. Remember that. Okay, I hope that is clear. Yes, sure Pramesh, why not? I'll give the shout out for the next winner as well, just like I did it for this time. Now, before I tell you more about current, let me give you a very important announcement because I need to make it. Guys, remember I was talking about the crash course for all the 12th standard and the dropper students. So there is a very cool thing that has happened recently and let me tell you about it. So remember, the crash course is just a course for those 12th and dropper students who do not want to get into subscription and do not want those extra micro courses, extra preparation for KVPY, or do not want those additional board preparation, etc., etc. You just want to focus only on JEE or NEET, then yes, there is one option for you. That is, you get 120 sessions where entire syllabus is completed. Then you get doubt solving from class teachers, from doubt experts, subject matter experts, all throughout the day till the night. And then 10 full syllabus and 10 part test series. That's what you get. And you also get tips and tricks sessions, motivational sessions during this course. And also it's a two-way course. It's not like one way. You can interact with the teacher, you can interact with other students. So there is chat box and everything out there along with the doubt section as well. So this is the crash course and you are not late for it. Remember, you will never miss the crash course no matter when you join, because the crash course has been designed in such a way, no matter when you join in, the entire syllabus gets completed, because there is a cycle running. So that cycle is running. So if you join here, you will complete it like this. If you join here, you will complete it like this. So that cycle of topics is there. So that's why you will never miss. That's the way it has been designed. So I'll tell you what is the best part. Right now, the offer going on is 25% only for the next 2 days. That's it. Only for the next 2 days. Remember, I was giving you 20% off 10,000. On 10,000, I used to give it to you for 8,000. Only today, tomorrow, and maybe till max Sunday, I think the offer is for 25%. You will get 2,500 rupees off directly, flat off. And how do you get it? It's very simple, guys. SHCC, that's your coupon code. The link for joining that crash course is in the description box below. And do not forget to share that link as well as the coupon code to get this 2,500, which is 25% off. Share it with your friends, relatives, cousins, whosoever will need it. All right. So, Bunny, I might not be teaching in the crash course, but there are very good teachers just like me who will be teaching in the crash course. Let me assure you that. All right. Yes, the crash course will be till the JEE Mains examination. Yes, it will be till the JEE Mains exam. Yes, throughout. Yes, as long as it takes for the JEE Mains exam. Correct. Okay. So potential difference is like, remember voltages? So understand, just like if you have 2 columns of water or 2 buckets or 2 test tubes or 2 columns, in both water is filled till the same height, then their energy is same. Correct? Their potential energy gravity wise is same. But let's say one has more water, one has less water. So what will happen? Gravity wise, this water has more potential energy, this water has less potential energy. What will happen when you connect them? The water from higher energy will go towards lower energy. Same thing happens in a battery. In battery, the 2 terminals or the power source, when the 2 terminals are there, what does it make? A potential difference. So one is at higher potential, one is at lower potential. So what flows when there is potential difference? Charges flow. I hope that is clear then. Okay, somebody was asking, SK Sultan, I hope that's fine. Okay. Yeah, but that's a very good, Ryan. That's the official definition, like unit wise. Yes, correct. So let's get going. All right. So Achut, please don't spam, please don't spam. Don't keep saying the same thing again and again. All right, I read your comment, fine. Maintain that decorum. All right. So now, like somebody was asking some time back, remember, it's the electrons which flow this way, but the current will always flow the opposite way. Electrons are negative charges. Current is the flow of positive charges. Remember one more thing. Whenever you have current always flows from higher potential to lower potential. Remember that. So let me mark it over there. This plus stands for higher potential. So this could be like the positive terminal of the battery. This stands for the lower potential, like the negative terminal of the battery. So current will be flowing like this, but the electrons will be moving like that, because all these are, remember, negative charges. Do not forget that. These are free electrons. These are free electrons. Now, how do I define current? Current is the rate at which charges flow in a conductor. So current I is nothing but the charge that flows divided by the time taken by it. So you can say it is Q divided by T. So amount of charge divided by the time. And obviously when 1 coulomb flows in 1 second, that is called as 1 ampere. So that's the unit of charge which you should know. So this is nothing but the unit of current. 1 ampere is when 1 coulomb of charge flows in 1 second. Now 1 ampere is generally a huge value of current. So if that much current flows through your body, you are definitely going to be roasted. Understand? So this is a very huge value of current. So is that clear till this point? Everything? Alright? Why we take VSG? That's only because of convention. That's all. Yes, Arundhati, if you have understood electrostatics, current electricity is easier. Yes. So yes, Saurabh, we are going to come to drift velocity as well. Is that clear, everyone? Okay. So let's get going. Okay. So this is how the electrons move. Okay. So actually there is one more reason, guys. What happened is, before people really discovered that actually in a conductor it's the electrons which move, people used to think long time back it's the positive charges that move in a conductor. So what did people think? People thought positive charges move. But then scientists like Hall and all that, they discovered actually it's the electrons which move and not the positive charges which move. That's when people realized, oh, all these years we have been assuming positive charges move, but now we discovered it's the electrons which move exactly in the opposite direction. But then they thought, oh, all these years we have been taking flow from positive to negative, so we should not change it. It's like convention. So because of historical reasons, so they continued that trend in spite of discovering that electrons move in the opposite direction. I hope that makes more sense. Asmi, you have been eyeing on my jacket for a long time now. Okay, now next quantity, guys, is called current density. So look at these electrons or whatever charges which are flowing through a section of a wire or a conductor. Now how many charges flow per unit time per unit area? So that is called as the current density. So that's the current density, guys. The current which flows per unit cross section is called as the current density. So let me write down. So current density is nothing but current flowing per unit cross sectional area, and J is equal to current divided by area. So I is the current, A is the area of cross section. That's the formula for current density. Please keep in mind that this is having a unit of how much? Ampere per meter square. That is the unit of current density. One more important thing, it is a vector. Yes, it's a vector. So J bar has the direction. Which direction is it having? It's the same as the direction of current. Very important. So it has the same direction as that of the direction of the current. Very important. In fact, you can write it in vector form also. I'll tell you how. So the vector form or the vector notation is, so I hope I can erase this now because I hope you have written it down. So the vector form of writing J is like this. I is equal to J vector dot area vector. This is the vector way of writing it. Remember, this is a dot product. Current is a scalar quantity. This is a dot product. Remember that. So this current, remember, is a scalar. Current is a scalar. J is a vector. Area is also vector. Remember, we have defined area as a vector quantity even in Gauss's law. So remember, I can take area as a vector quantity like this. by taking it as a perpendicular to that area. So area vector dot current density will give you current. Remember that. J cos theta. Yes, uncharted. All right. How, sir, it is vector? It has been defined as a vector quantity for convenience. So you can define anything, like how area is a vector quantity, we have defined it for convenience. All right. So that's how it is, Saurav. Okay. So you can define it like a vector quantity, as long as it follows the rules of vector addition and subtraction, only then. Thank you, Pavitra. All right, crystal clear. Thank you, Ryan. All right, Sneha. Okay, Saurav. Okay, great. Chalo, let's get going. Now that you know about current density, now I'm going to give you the next concept. Guys, I'll tell you an interesting problem. One very nice problem just struck my head, and let's see how many of you can answer it after I tell you this. Now, what is this drift velocity? Observe this animation. You can see what are these red dots? These red dots are your nucleus, big heavy things, they will not move. These tiny things, they are the small electrons, tuck, free. And what are these free electrons doing? They are moving from high potential to low potential, or basically they are moving, drifting. So they are moving, tuck, they are colliding. Understand, they are not moving in a straight line path. Their path is not easy, just like your path for cracking the JEE or the NEET examination is not so straightforward. So they will encounter a lot of collisions among themselves and also even the nucleus out there. So what will happen is that, understand, they will be moving at a speed, with certain speed, from one side to the other. The average speed with which the electrons or the charge carriers move is called as the drift velocity. So what is the drift speed or drift velocity? This is nothing but the average velocity of the charge carriers when potential difference is applied. Okay, so very important. When potential difference is applied, that's the direction of that's the meaning of drift velocity. What is the direction of drift velocity? What is the average velocity with which these electrons drift? Understand, these electrons drift. The drift velocity direction wise is opposite to the current's direction. So whatever is the direction of the current, exactly opposite to that, the drift velocity will be. It's obvious, isn't it? Remember, I just told you, what are these tiny things? These tiny things are nothing but electrons. And if electrons move like this, current will be moving this way. So it's always opposite to the flow of current. I hope this is clear. Glorious space, I'm very good. Come on, let's get going with the session. All right. Now, what is the formula for drift velocity? Very simple one, guys. I'll make you remember and you'll love this way of remembering. I hope. No problem, Ankit. Remember, guys, there is some very important company called as for graphics card. You know what is it called? Nvidia. If you have been into gaming and all that, you would have heard about that gaming company called as Nvidia. How many of you have heard it? Put it up in the chat box. So guys, just remember Nvidia and that's it. Your job is done. I is equal to N V D E into A. That's it. This is the formula. This is the formula for remembering the drift velocity. Now you'll be like, sir, what are these terms? Don't worry, I will tell you guys. Very simple. So I is obviously current, no doubt. So this is nothing but current. I'll come to this. What is this A? That is nothing but area of the cross section. What is E? E is your standard value, 1.6 into 10 to the power minus 19 coulomb. That's standard, E's value. What is this VD? I just told you, VD is nothing but your drift velocity. What is this N? These are your charge carriers per unit volume. So per unit volume, how many charge carriers are there? That is that small n. Do you know this value? Don't worry, it will be given to you. Okay, so it will be given to you. So it's very simple to calculate. All right. Correct. Number of molecules per unit volume per meter cube. Sometimes they trick and they give you total carriers. So you have to divide it by the volume of that wire, that is the volume of the cylinder if it is cylindrical, to get the value of small n. I hope this is clear. Yes, yes. So that's the, yes. So I hope now you will remember this formula. Current is NVDA. But remember that D is a subscript. D is not as a variable, it's a subscript. Okay, clear? Very good. All right, all right. Spare the time, grammar. Come on, join in, join in, join in. No problem, no problem. All right, thank you, Pavitra, Princey, Sneha. Thanks for all the love. Okay, join in, spare. Just hit the subscribe button and just hit the like button also, guys, in case you are loving all these formulas. If you have not already liked, or if you have subscribed to this channel, do that right now. If you have subscribed, well and good. And if you have liked, well and good. So if you're not liked, do that right away. Yes, do not forget to do that. Okay, so now let's do some questions based on this. So that is your drift velocity. So let's see how many of you are going to get this question. All right, I'm going to put a timer, guys, of 1 minute. And let's see how many of you get this. A current of 3.2 ampere flowing in a conductor. The number of electrons passing per second through the conductor will be how much? Come on, guys. Kya baat hai, Princey? Thank you very much. Yeah, that's why those 2 hearts, I guess. Very good, Saurav. Very good. What is bore boost? Sai. Thank you, Ankit. All right, spare time. You are going to get a lot of love and affection in this Enthuse family. Let me assure you with that. Because we are a family. All right, solo gamers, Uncharted, a lot of people saying A, some people saying B, VSG saying A. Okay, come on, come on, come on, come on. Atharv, I just showed you some visualizations. I hope you saw those visualizations, Atharv, those animations of flow of electrons and all that. I hope you are there during that time. So let me tell you guys, the correct answer is A, and let me tell you why it is A. So remember, current is flow of charges per unit time. So I was Q by T. Okay, so here is what I can do. Charge which is flowing is number of electrons into each electron's charge divided by time. Number of electrons into 1 electron's charge will give me the total charge. Now just rearrange this. What will you get? N by T will be nothing but I by E. Now what is this N by T? Number of electrons passing per second. This is what I want. So electrons per unit time that are passing will be current. What is the current? 3.2 divided by what is the charge? 1.6 into 10 to the power minus 19. So just do that, guys. What will you get? Obviously you are going to get 2 into 10 to the power 19, and that's the answer. I hope you now understood how this problem has to be done. I've shown you all these steps systematically. All right, straightforward question. Okay, so I hope you have got some confidence boost over here. Satharu, I just mentioned what about the visualization. Chalo, let's get to the next question. So this is on drift velocity. A current of 10 amperes is maintained in a conductor of cross-sectional area 10 to the power minus 4 meters square. If the number density of free electrons in that conductor is 9 into 10 to the power 28 per meter cube, then what is the drift velocity of the electrons equal to? Okay, chalo, calculate it. I'll give you a little bit extra time. I'll give you 1 minute 20 seconds. Come on, chalo, start solving it now. Spare time grammar, there is a separate session just to tell you which books to use for JEE or NEET, we have conducted a special session. Can you just watch that after this session is over? It's there in our playlist only, in our channel. N value has been given, VSG. N value has been given. Yes, Sneha, I'll be giving you that question now. After this, I'm going to give you that question which has hit my mind. Thank you for reminding me. All right. Yes, sure, 17S, I will do that. Come on, guys. Thank you, Alu. Nice name you have. All right, let's see whatever the answer is. Time is up. Many of you are saying C, some of you are saying something else. Most of you are saying C or D. So guys, I think the correct answer is A. Now let me tell you how to get to that correct answer. See, I just told you, remember that formula? I is equal to N drift velocity into E into A, NVIDIA. So current, is it given? Yes, current is 10 amperes. N, number of charge carriers. Who are the charge carriers? Free electrons. Per unit volume, oh, that is only given to us. How much is it? 9 into 10 to the power 28 into drift velocity, that's what we need to find. Electron charge 1.6 into 10 to the power minus 19. Area of cross section 10 to the power minus 4. Now just rearrange it and you will get the drift velocity, guys. Come on, just do that rearrangement. Just calculate it, recalculate it and see whether you have missed some calculations. Come on, do it again and see. Come on, guys, I think it should come out to be 6.9. Just check it out. I think you would have missed that 1.6. Many of you missed that 1.6, or some of you probably has missed this only. So that's why you got the wrong answer. So guys, I think it should be 6.9 into 10 to the power minus 6 meters per second. Just check this out. No problem, Ryan. See, Ryan, I have told one more trick in the morning during the Menti session. Now look at the significant numbers. What are the significant numbers? This will help you in JEE Mains, NEET, any competitive exam. 6.9, 5.5, 1, 4.5. So do not calculate all those things. Forget the powers of 10. Just look at this number and just look at this number. Just multiply 9 into 16. 9, 16, you know. Just take the reciprocal of that. Whatever number you get, I think it will be something like this, 69 or 0.69 or something like that. So if you see anywhere 69 or 0.69, just mark it. Do not worry about the powers of 10. I hope that is clear. Yes, only calculate that number. Correct, Saurabh? Understood? So that's the trick which you can use. Yes, that's the trick to make the calculations faster. Okay, now Sneha, good, you reminded me. Yes. That I told you one question clicked my mind. Now see, this is the question that clicks my mind, that look at this value 10 to the power minus 6, guys. Very small velocity. I mean, it's like 6.9 micrometer per second. Oh, micrometer is so small, like the size of an amoeba. Yeah, this is so small. Bacteria, virus ka size ka hai ye. Very small. So my question is, if electrons move at such a slow speed, how is it that when I turn on the switch, instantaneously the light will start, the fan will start moving, the TV will turn on, the AC will start? How is it? How is it? Have you ever thought? What do you guys say? How is it? So spare time, we will always conduct our live classes at 7 p.m. Physics, chemistry 5 o'clock and maths 4 o'clock, always. Electrons are everywhere on the live wire. Yes, there are many electrons. Actually, I'll tell you, yeah, there are electrons everywhere. In fact, all the wire, throughout the wire, whatever electrons are there, all the electrons start moving. It's not that if it's a long wire, let's say this is the wire and this was the switch, and the moment you turned on that switch, okay, so the moment you turned on the switch, it's not that this electron has to move, then it will tell, oh hey, next electron, move, okay, then the next electron will be like, okay, let me also move at this small speed, then it will move slowly like a sloth, and then it will be like, hey, next electron, please move, and then the next electron moves. And if that happens, then you know how it will be, like you turn on the switch now and maybe after a year or two, then that light will turn on, and that will be like worse than a tube light. So that's not what happens. What happens, guys, is that the moment you turn on the switch, the electric field travels at the speed of light, and it tells everyone, hey, all you losers, or hey, all you sloths, move it. Yes, and they'll be like, I like to move it, and they will start moving instantaneously, because electric field will move at the speed of light, 3 into 10 to the power 8 meters per second. That's very fast. I hope this is clear. I hope this is clear, guys. Everyone understood? Yes? Very good, guys. Very good. So this was the brilliant question that struck my mind. Yes, if more resistance is present, Shivam, then they will move slowly. Correct. Very good, very good, very good, very good. Excellent, Asmi. Asmi has been looking at me with very evil eyes. He has been eyeing on my sweatshirt, guys. I need to be a little bit safe. Okay. So, what is resistance? I'm coming to it, Barney. Don't worry. Okay, Banu Prakash. All right. So, we have done this question. Now, what is resistance? Excellent timing. Who is this guy? Barney, I think you have some crystal ball in front of you. You can predict what I'm going to do next. Okay, so what is resistance? What is resistance? What is resistance? Okay, I'll tell you what resistance is. These charges want to move, right, from high potential to low potential, but somebody will be there, villain, like resistance is the villain of the story, remember that. So always from high potential to low potential, things will like to move, but resistance will prevent it. Now I'll be like, why is there a villain in the first place? Simple fact. When these electrons, look at this electron, Bechara electron, look at this Bechara electron, how it has to find its way through. It's like going in that crowded station in Mumbai or Calcutta, where so many local trains are there, so many people around, and you have to find your way. Hey, excuse me, hey, excuse me, hey, excuse me, hey, excuse me. And that's how it's going to go. It has to find its way through. So there is a resistance out there for all the electrons to move. So that's resistance, guys. So electrons will collide with themselves and the nuclei of other atoms and etc, etc. That's why resistance comes. I hope this is clear. Yes. How many of you have been in a local train in Mumbai? You will understand what resistance to the flow of motion of a person is. Have you experienced that? If you have, let me know in the chat box. Yes. Yes. Aishwarya has. Uncharted, Sneha, Asmi also has. Wow, look at that, look at that. Very good, very good. Very high resistance is Saurav. Sneha, okay, very good, very good, very good. So that is resistance, guys. So resistance always is basically the restriction or opposition to the flow of electrons. So now you will be like, what is the symbol? Everybody knows, but just for formal discussion, this is a symbol of resistance and it is measured in ohms, or basically you just put this symbol. So that's the unit of resistance. All right. Now, what does resistance depend on? Let's talk about it. So I hope you have written down all these things. Resistance is the, opposition to the flow of charges. It restricts the motion of the electrons. More the resistance, more the restriction, you can say. Now, what does this resistance depend on? Let's see what this Pandu has to tell us. Let's see. All right. Of course, spare time you can talk JEE 2021. Of course, why not? Yes, Bhanu Prakash, don't worry. I'm going to give you Ohm's law also. Yes. So now, first, let's talk about resistance. Then I'll come to Ohm's law. Hold on. Okay. So factors which affect resistance are the length of a wire and the area of that wire or the conductor. So experimentally it's found out that resistance is proportional to length and resistance is inversely proportional to the area of cross section. So more the length, imagine I tell you, you have to travel 2 kilometers instead of 100 meters. You'll be like, oh my god, that too on that crowded platform of that Mumbai railway station. It's going to be very hard, guys, if you have to travel long in that crowded platform, isn't it? So resistance increases when length increases. And what about area? I tell you, hey, guess what? The same number of people are there, but they are on a big platform. You know, the platform is not narrow, it's a big platform. So we're like, okay, maybe I can do it. The resistance is going to be slightly less because, you know, the people are going to be more scattered. I'm not going to bump into so many people. So maybe my way will be a little bit easy. So hence, it is inversely proportional to the area. I hope that makes sense to you. So resistance is given as rho L by A. This is the formula. All right. Now, what is this rho? This rho is called as the resistivity. Resistivity of a material. Okay, so this is the resistivity of a material. So it completely obviously depends on the material itself. So each material like copper, aluminum, wood, etc., will have different values itself of rho. Yes. So something which has very good conduction properties, it has very less resistivity. If something resists the current a lot, very bad conductor, it will have more resistivity. I hope that makes sense. So resistivity is nothing but resistance into area per unit length. That's how you can work it out. All right. So Bhanu Prakash, resistivity is that property which tells you how much it is going to resist the flow of current. That's how it is. All right. Now we'll come to that, Ankit. Yes. All right. I hope this is clear. Yes. If this is clear, I hope you have written down all the formulas. Now let me give you some values. Don't have to remember. This is just for your reference. Look at that. Silver, 10 to the power minus 8. So small. That's the resistivity. That's the resistivity of silver. Very good conductor. Look at copper. Also in the range of 10 to the power minus 8, but slightly more resistance than silver, but nevertheless very good. Look at aluminum. 2.65 into 10 to the power minus 8. Not that bad, but still a good thing. Look at iron. These are all good conductors. Look at carbon. Carbon is 10 to the power minus 5. Not that great a conductor. Look at glass. Oh my god, it went to 10 to the power 9. Yeah, 10 to the power 9. This was minus. Very bad conductor. Look at rubber. 10 to the power 13. Insane. It's not definitely going to allow any current. I hope that's clear. Obviously, you don't have to remember this, just to give you some idea. All right, Omkar Nagarajan, welcome to this channel. Come on. I hope you have already subscribed so that you will not miss out any of the videos. Now, coming to the next part, dependence of resistance on temperature. How does resistance change with temperature? It's found that if you increase the temperature, hot wire, this is like angry people on that railway station. Understand? So if you enter a railway station and all the people are angry, they're bumping into each other, so you are going to find it hard to find your way through. So move the resistance. So basically, as temperature increases, resistance also increases, my dear friends. I hope this is clear. Okay. So let's write it down. So what is the formula? The formula is the change in the resistance, okay, is equal to R naught alpha delta T. This is the formula. Now I'll tell you what each term is, don't worry. So this is the formula approximately. Now what is delta R? That is the change in resistance. What is R naught? Original, or I can say initial, before changing the temperature, initial resistance. What is alpha? It's a material value like coefficient of friction, resistivity, it's a value, depends on the material. It's called as the coefficient of thermal resistance, and this delta T is obviously how much did you change in temperature. So this is the change in temperature. Does this formula remind you of some other formula from some other chapter? Does it? Does it? Does it remind you of something? Mobility is in some other chapter, Dinesh, that will come in semiconductor. Don't worry. Yes, this was there. Yes, this was there in some other chapter also. Coefficient of linear expansion, thermodynamics, correct, very good. This was there in that also. Change in length is original length into alpha into delta T, but that alpha was different alpha. That was called coefficient of linear expansion. Similarly, change in volume was original volume into gamma delta T. That gamma was coefficient of volume expansion. Very similar formulas. I hope you can see that. Yes, correct. Solids expansion and all that. Excellente, guys. Excellente. So these formulas are identical. Now, what does it mean that if some material has a large value of alpha, it means that if something has very large value of alpha, so the moment you change the temperature, maybe the temperature changes from day to night, then the resistance will also change significantly. If some material has low value of alpha, then when you change the temperature, the resistance won't change so much. So ideally, depending on the type of application, one would want alpha to be large or small depending on the type of application. Generally, you wouldn't want a large alpha because you do not want too many changes in the current happening around your wires of your house, because then things will change significantly. Unless you are trying to measure the temperature only by resistance. If you are trying to measure temperature, oh, at this temperature this is the resistance, at this temperature that is the resistance. So you would want a very large value of alpha so that you can easily see the change in the resistance. I hope that's clear. Okay, I hope that's clear, guys. Aryan, welcome, join in. Yes, Ryan, Ryan. All right, so let's get going to the next set of questions. Now, before that, Ohm's law. So what does Ohm's law say? Ohm found out that when you measure the voltage and the current which pass through a resistor, or the voltage across a resistor and the current which passes through the resistance, then he found out that the potential difference is directly proportional to the current. This is inside a resistance. And that's how we write V is equal to IR. So this is Ohm's law, and you would have done that in school maybe, or you will do it whenever you will get back to college and labs and stuff like that. So voltage is proportional to the current, and the proportionality constant is resistance. So if you draw a graph and you see the line, you will see that line will be a straight line, it's not curved. So this is how it is. Generally you take few points and you join a line and you see that it's a nice straight line. That's what happens in the lab. So you measure the voltage current at different voltages, and that's how you draw that line. I hope that's clear. Thank you, SP. All right, now let me tell you what will be resistance from this graph. Guys, come on, is resistance dV by di, or is it di by dV, or is it something else only? Come on, let me see how many of you get it. Or is it something else? Is resistance dV by di, di by dV, or something else? Come on, guys. dV by di? Oh, let me tell you guys, you know, that is why JEE and NEET will put questions exactly like this, so that you will go and fall into that pit. You will fall into that tip. Dinesh, by practice, yeah, by practice. All right. So I'll tell you what, resistance is not dV by di or di by dV, it is V by I. Meaning, if you measure at this point and at this point, let's say it is, I don't know, 4 volts and maybe this is 2 amperes, example. So the resistance is just, remember, voltage by current. So 4 by 2, that is just 2 ohms. That's it. So this is just voltage by current. It's not dV by di. Okay, be careful. So it's just voltage by current. Okay, okay, be careful. A lot of people get confused over here. Okay, great. Chalo, let's get going. Don't worry guys, if you keep attending my sessions, believe me, by the time you write your actual NEET, JEE, Mains, BIT, SAT, CET examination, I would have dealt with so many questions and so many kinds of traps which the examiner, I know what kind of questions the examiner is going to keep for you. They will lay some traps, this trap, that trap, and exactly students get trapped in those traps. So I will tell you all those traps. So if you follow my sessions regularly, that is, else you will be missing few traps. So what happens, the moment you miss a lecture, you will be missing few traps. And that's exactly where you will fall. And then you will lose marks and then you will lose ranks. So if you do not want to fall into those traps, you have to attend all the sessions. All right. Oops, what is this? I don't want to start coding lessons now. Okay. So last thing over here, electric field. This is one formula which many people don't give you. Let me tell you this. Remember, voltage is I into R, correct? Voltage is I into R. I just told you this is nothing but Ohm's law. Okay, so now here is what we will do. What can we do? Let's see. I by A, and if I have divided by A, I need to also multiply by A, and R, and here voltage by length. So I'll have to also divide by length over here. I just maintained the equality. You'll be like, sir, why did you do this? Have you gone crazy? No, don't worry. You will see why I have done this. Guys, try to recollect. Electric field was delta V by delta R. Do you remember that? Electric field, electrostatics, dV by dr. I have told you that. So what is V? Voltage difference. What is L? Distance across which you get that voltage. So what will this be? Isn't this going to be electric field? Because this is very similar to electric field is delta V by delta R. This is the formula I use. Now think about this. Oh, I know what this is. This is current density. J is I by A. So just substitute J over here. Now you'll be like, sir, what is this? Hold on. Remember, R was rho L by A. This was the formula. So think, what is RA by L? What will be RA by L? You can easily guess it. What is it? It is nothing but rho. That's it. This is the formula. This is the formula which you have to remember. Correct. Now this is so important. Oh, by the way, this is a vector equation. So there is a vector symbol over here. E is rho J. E is rho J. Okay. Or some people also try to remember it like this. Rho J. That's it. Okay, so you can remember it by funny pronunciations as well. But anyways, it's very similar to V is equal to IR. So it's up to you. All right, all right. E stands for electric field. जैसे होता है ना that Roja is a name of a girl. So Roje, like lot of Rojas, Roje. Okay. So that's how you can remember it. Okay, okay. So E is electric field, J is current density, rho is resistivity, guys. So you'll be like, sir, what is this used for? Remember at the start of my session today, what did I tell you guys? In electrostatics, electric field inside a conductor is zero. But in electrodynamics, when current moves, what happens? Electric field is there. Now you will be wondering, what is the value of this electric field? This is the value of the electric field. Resistivity, easy, piece of cake. It will be given, or you can find out. J, oh come on, current by area. That's it. You can find the electric field inside a conductor. Sushil, but see, this is the English channel, yeah? All right. Okay, not that Friday fasting, that is, oh, that's a different Roja. Okay. So let's get going, guys. Here is a question coming up on your screen. Very interesting, fascinating question. Mercury resistance, the resistance of a mercury column when it is in a tube is 4 ohms. Now that same mercury is poured into another tube which has half the radius. Same mercury, keep that in mind. So things will change. The resistance of that column will be. So I'll just tell you how the diagram looks like. So this was that mercury in a tube. What did you do? This was that tube, something like this. Okay, you have transferred it into a tube which has got half the radius. So what do you think will happen to the new resistance? Come on guys, let's see how many of you get this really quick. I'll start the countdown timer and here it is now. 1 minute. I've given you the hint also. Oh yes, Asmi, no problem. All the best, all the best. SP, I'm very good. I hope you are fine and I hope you have already subscribed to our channel or else you'll miss all the lectures, alright? Okay. Let's see how many of you get it. Chinmay says A. New person, solo gamer says A. Hardik says A. Alright. A lot of you are saying A. Banu Prakash says C. Aishwarya says A. Ankit says A. Okay. Asmi says ABCD. ABCD is the dance that Asmi is going to do. Alright. Uncharted said D. Okay. Guess what? Uncharted, I think, is right. Where is that Uncharted? Yes, Uncharted will be right, guys. That is the correct answer. You'll be like, what the hell? How the hell is it 64 ohms? How the hell is it 64 ohms? I don't know. I'm just guessing, huh? Maybe I'm also wrong. Let's see. So, guys, you forgot one thing. It is transferred to another tube. Okay, be careful. The original radius was R, correct? Original radius was R. So, the original area of cross section will be A, correct? And what is A? A is pi R square. Now think about it. Now think about it, guys. When you put it in a new tube or new container whose radius is R by 2, think what the new area will be. I feel it will be 1/4 of the original area. Yes, 1/4. Why 1/4? Yeah, R square. If you halve the radius, area will become 1/4 square, na? Is that clear? All right. I hope this is clear. Bhat Nazir, welcome. All right. Now there is a catch. You'll be like, oh, now I know. Area becomes 1/4. So area becomes 1/4. Resistance will become 4 times. So 4 4s are 16. Wrong. Guys, why do you forget? The mercury remains the same. So the height of that mercury will increase. It's a thin tube. The height will increase to keep the volume same. Volume has to be same. How can you forget? So if area becomes 1/4 and the original length was L, what will be the new length? Think about it. Volume is area into length. Area becomes 1/4, so length will become 4L. Is that clear? Forgot the height, है ना? That's exactly the emoticon you should be giving right now. Very good. Exactly. So guys, the resistance is rho L by A. A became 1/4, L became 4 times. So the resistance became 16 times. 16 times. Oops, ho gaya. Got it? So hence bulb jala, batti. Okay, so guys, the answer is not 16, it is 64. Okay, so where is it? 4 into 16, that's 64 ohms. So uncharted got it. Got it? Got it, got it, got it. Yes, Divajyoti, yes, Chinmay, yes, Hardik, yes, Tanmay. Correct. So that's exactly the trap which the examiner is going to lay. They know, kids, psychology. You know how your psychology works? It's like you change one thing, you'll be like, oh, this is changing. But you forget, oh, that thing also changed. Who is going to look there? So guys, keep your eyes everywhere. Remember, in the exam also, when many things, many variables are there in a formula and one variable changes, everybody looks at that variable. That change, okay, if this changes 2 times, that will change 4 times. But you forget, how will that change affect the other variables? Do not forget that. That's another trick I'm teaching you today. All right, Science Priya, the bulb has glowed. Next, chalo, let's see how many of you get this. Come on, come on, come on. Come on, come on, the radio on. Come on guys, come on. Do this question. Yes, Ryan, you should look at the questions in different angles. Come on guys. Specific resistivity. Actually, resistivity itself is specific. Rishi, this is class 12th and class 11th both. So I'm teaching class 11th on Monday, Tuesday, Wednesdays, and class 12th on Thursday, Friday, and Saturday. Come on, come on, come on, guys. Okay, so yes, that's me. I know. Come on, come on, concentrate. Let's do this. Okay, the correct answer is 9 by 16. Many of you got answer B. Very good, very good, very good, Tanmay. Very good, Uncharted. Very good, Saurav. Very good, Trushita. Very good, Bhanu Prakash and Princey and others whose names I would have skipped by mistake. All right. So here is the thing. So two different wires have different specific. Specific resistivity is same as resistivity. Forget it. Lengths, areas, and cross sections are given. Everything is given. Okay, area of cross section, everything is given. So just use the formula. What is the ratio of the resistance? R1 by R2 will be rho 1 L1 by A1, and here it will be rho 2 L2 by A2. So just use that. So it will be rho 1 by rho 2, and it will be A2 by A1, and it will be L1 by L2. So what is rho 1 by rho 2? Rho 1 by rho 2, come on, come on, come on. Rho 1 by rho 2 is 3 by 4, guys. What is A2 by A1? See, area of cross section is 8:27. Do not forget to flip it, else you will get wrong answer. So 27 by 8. And L1 by L2, this is going to be 2:9 as it is. So 2 by 9. And I believe that should give you the answer as 9:16. I hope that's clear. All right, everyone, is it clear? Is it clear, guys? Let me know. Very good, very good, very good. Okay, let's go ahead. Let's go ahead. So let's see the next question. Very tricky. Let's see how many of you get this. Let's see how many of you get this. Very tricky question. Many of you are going to fall for it. Come on, come on. Let's see how many of you get it. I'll give you 1 minute timer, guys. Starting the 1 minute timer in a bit. So understand this is a current versus voltage graphs, and the graphs are shown for two different temperatures, T1 and T2. Then whose temperature is more, assuming they are for the same resistance, you are passing the current and the voltage but at two different temperatures. So which graph has more temperature? Starting the quiz now. Let's see. Laddu. Chalo, if it is Laddu Bhanu Prakash, then let's see whether you get that Laddu question or not. Okay, we have clear-cut division. Some are saying A, some are saying C. Nijarsan, long time no see? Or were you not participating in the chat box? Come on, you need to be active in the chat box. Vijaya says third option. Trushita says A. Sneha says C. Uncharted says A. Oh my God, Asmi, Abhishek sir will also be angry on you. So I hope you are on two screens right now. Sanidhya says, how should I get above 95 percentile? Sanidhya, we have done a video on that, how to score 200 plus on this very own channel, We Enthuse. Go to the playlist, check it out, it is there. Alright, time is getting over, guys. Come on, let's see. Okay guys, the answer is T1 less than T2, but how? Okay, so let's see. Guys, this is current versus voltage. First thing keep in mind. Now, understand, for this graph, if you check, alright, the ratio for the first graph, current by voltage. What is current by voltage going to give you? Is it going to give you resistance? No, it is going to give you 1 by resistance, guys, correct? Because V is equal to IR. So, the graph which has higher value of I by V, look at that, I by V is higher for T1 if you compare it with the other one. Alright, so look at the other graph, the I by V is smaller. Alright, so if you want, you can take it at the same place, but I have just shown you how you should calculate the value of I by V. So the one which has more I by V has more 1 by R, but the value of resistance will be less. The value of resistance will be less. Okay, who has more I by V? Graph 1 has more I by V than graph 2. So the resistance of 1 is lesser than resistance of 2. Correct? I hope this is clear. Now what is it that I told you before? Resistance increases, temperature also increases, or vice versa. So hence T1 should be less than T2. I hope that is clear. T1 less than T2. Is that understood now? Very good. Very good, Vamshi. Very good, Hardik. Very good, Princey. Very good, Ryan. Very good. Yes, correct. So let's get going to the next question. Let's talk about power. That's the last topic for today, and then we'll be calling it off a night. Oh, I forgot to make an announcement. How bad of me. Guys, you know what? I forgot to make an announcement. Yeah, exactly. Let me tell you, now that I remember it. Some of you probably might know what that announcement is, but let me tell you guys, tomorrow at 7 p.m. is going to be an exciting session. Because I'm going to give some very important stuff and important news and important tips tomorrow. So stay tuned at 7 p.m. And I believe you should get your friends, you should get all the JEE aspirants along with you for every session, not just for tomorrow's session, but also for every other session that you're going to come over here. Because aren't you guys having fun with each other over here on this live chat? Aren't you guys behaving like a family? So imagine this family becomes bigger. It will be so cool, guys. So get your families, your cousins who are preparing for JEE, preparing for NEET, preparing for NTSC, preparing for their 12th. preparing for any competitive exams right over here. Make this family grow bigger. Do not forget to share this video, and also do not forget tomorrow 7 p.m. special session from my side. You'll see what it is soon. All right, and guys, you have to stay updated. Then you can also follow me on Instagram, Shreyas_Vedantu. That's my Instagram IG handle. So do not forget to stay tuned over there. I'm going to post, I remember I have wanted to post one very exciting video. So I'm going to post it maybe tonight itself or maybe tomorrow morning. So I'll post it. All right, so do not forget to see that very exciting 1-minute short clip tomorrow. All right. So let's talk about electrical power. So what is electrical power? Whenever electrons flow through a wire, remember they always collide with those other electrons and other atoms out there. So they create some heat. So that heat which is developed is a loss. It's lost form of energy. That energy which is lost is basically, oops, where did it go? Yeah. So that electrical power is given by I squared into R. You can also write it as V squared by R. One and the same thing. So this is obviously in joules per second or watts. So this is the amount of energy lost per unit time. This is the energy which is lost. Now there are a lot of applications of this. So if you pass more current through a resistance, you will see a lot of heating which is happening. Okay, yes. So, oh yeah, you like the animation? Glad. So, a lot of applications, guys. Heating, heaters, especially in north of India. I'm pretty sure you will be using heaters a lot over there because you need that, guys. I mean, come on, the temperatures are so low right now. Even in Bangalore, guys, the temperatures are so low. Look at me wearing this jacket. Yeah. So anyways, so whenever current passes through a very high resistance, it will develop heat and will provide you warmth. So that is the formula which I just gave you. Hello Hema, welcome. Join in. All right. So let's see if you can solve this question, guys. Come on. Let's see how many of you can solve this question. Come on. Come on, guys. Come on. Let's see. Okay, Dinesh says something. Yes, heat and power both depend on the resistance. Yes, Saurav. Hello, Barry Vicky, welcome. Okay, come on, guys. Okay, most of you have got the answer now. Very good. The correct answer is 1800 joules. Please understand, the question is what is the thermal energy produced. So that formula which I gave you was for the power, which was I squared R. Okay, but the heat which is produced will be power multiplied by the time. So hence it will be I squared R into the time for which it flows. What is the current? Where is the current? Current is 3. So 3 square. What is R? 20. And what is the time? T is 10. So that's it. Do this. It will be 1800 joules. So that's the amount of energy which will be produced by just passing you know how much? 3 amperes of current through just 20 ohms for just 10 seconds. 10 seconds will produce this much amount of energy. Crazy. I hope that's clear now. Oh well, yes, VSG, that can be also equal to the work depending on whether that heat is used for doing work. Yes, correct. All right. So, Princey, I have not put you on timeout. Yeah, matlab on anything. Okay. So let's see the last question for today's session. It's a very different kind of question. Let's see how many of you get it. It's slightly tricky. You will fall for the trap again over here. So the first one was a little bit easy. Most of you would have got it. So 200 volt bulb is rated at 40 watts. What will be the power consumed by each bulb if two such bulbs are connected in series across the same voltage of 200? Come on, let's see how many of you get it. Chalo, let's see. Guys, I'll put a timer now. Come on, come on, come on. 1 minute. 1 minute to go. Let's see how many of you get it. Oh yes. Well, Ashmi, I would love to visit Maharashtra after the pandemic is over, maybe. Neil, come on, come on, get going. Shara, come on. Okay, a lot of you are giving different answers. Come on, ask me, be serious for one time. Hardly 10 seconds to go. Okay, let's see how many of you are correct actually. Hardly 5 seconds now. Okay, time for revelation. All those people who said D. Muhammad Abdullah, where were you? How is the weather there? Where were you first? You tell me that. All right, so here is the way to solve this. First of all, this bulb when connected across 200 volts, how much was the power? 40 watts. Okay, now when two such identical bulbs are placed, what will happen? You are connecting it across 200 volts, but remember, each bulb will not get 200 volts. Each bulb will only get 100 volt and 100 volt. And why is it? Because they are connected in series. So each bulb, because they are identical, will have the same drop, 100 and 100. Understand that. So the power will also be different. It will be P1 and P1. So if I want to figure out what is that power loss, here is what I will do. Remember, power is equal to voltage square by R. Now the resistance of the bulb never changed. What changed? The voltage. So what happened to that voltage? It became half. So if the voltage became half, what will happen to V square? V square will become 1/4. Is that clear? I'll repeat. Since they were connected in series, each bulb will not get 200 volts. How much will it get? 100 and 100. Why? Because they are equal resistances. So the voltage will become half, V square will become 1/4. So power will also become 1/4. So what was the original power? 40 watts. So what will be P1? 1/4, which is 10 watts and 10 watts. Is that now clear? Yes, correct. Correct. That is the trick. And that's why many people fail. And I'll tell you one more question in this. The question will be, what is the total power consumed? Lot of people forget that total power was asked. They just figure out the answer was 10 watt. And in the option also there will be 10 watt. So they will mark the 10 watts. But they will forget, or they will misread the question, or they will not see what was asked in the question. A lot of people do that. So read the question. If it said, what is the total power lost? Then the answer will be 10 plus 10 and it will be 20. I hope that makes sense. Okay? Very good, very good. So that was the answer. So guys, do not forget about the JEE Mains crash course, which is going to start for you, and you have to enroll. And remember the offer that I mentioned you, exclusive offer just for the next 3 days till Sunday. I'm going to give you 25% off. Usual offer that I give you is 20% off. So now I'm going to give you 25% off. That's a big deal, guys. Please do not wait any more longer to join the crash course, guys, because you're going to get lots of test series, lots of assignments, doubt solving, live interaction, two-way interaction, and amazing master teachers just like me are going to teach in the crash course. So do not forget that. And also, let's not forget that you have to also join on this Telegram group where you're going to get all the amazing stuff like the extracts, which are the summaries of all the chapters, your homework solutions, your updates, and all the important notifications and stuff that we would be sharing with all of you. So this is our official group. Do not forget to join it. The link is in the bio and the description box below. All right. And I hope you have already liked it by now. I'm pretty sure that in case you haven't, do not forget to like this video. And if you are new to this channel, do not forget to subscribe this channel. And do not forget to share this joy with others by sharing this channel link with your friends, relatives, cousins, whosoever it is. All right. So I hope you guys have enjoyed. Rajkumar, 10 plus 10 is 20, right? That's why. Each bulb will give you 10 plus 10. That's why. All right. Okay, great. I hope that is clear now. All right. So anything else you want to ask, please put it up in the comment section, not in the live chat, below the video once the video ends, and I will be seeing all those comments and replying to all of that. So bye bye, take care, see you tomorrow at 7 p.m. This was Shreyas here, your master teacher for physics, going live at Vedantu. Bye bye.